Cerebrovascular disease. That's a mouthful, right? But it's a massive deal. It's one of the leading causes of death and disability all over the world. But what does that really mean? Well, it's the story of what happens when the blood supply to our most important organ, the brain, suddenly and catastrophically goes wrong.
So let's get right to it. What is actually happening inside your brain during a stroke? It's this sudden, dramatic event. And to really get our heads around it, we need to break down the science of what's going on moment by moment. Okay, so at its heart, the definition is actually pretty simple. Cerebrovascular disease is just a catch-all term for brain problems caused by, well, problems with its blood vessels. The best way to think about it is like this. Your brain has this incredibly complex and vital plumbing system, and when something goes wrong with the pipes, the whole house is in trouble. And that brings us right to the core of it all, what I'm calling the brain's plumbing problem. Because really, no matter how complicated the consequences get, it all boils down to just three basic ways the system can fail. It really is just these three things. First, you've got a thrombotic occlusion. That's like a clog, forming right there in the pipe. Second, an embolic occlusion. This is when a piece of gunk breaks off from somewhere else in the body, travels through the pipes, and gets wedged in a smaller vessel in the brain. And third, well, the pipe just bursts. That's a vascular rupture. See? A blocked drain or a burst pipe. That's pretty much the whole story. So, these three plumbing failures, they lead us down two very different paths. It's really a tale of two strokes. And here they are. On one side, you have the ischemic stroke. That's the blockage. The pipe is clogged, blood can't get through, and the brain tissue downstream starts to starve from lack of oxygen. It's a supply problem. Then, on the other side, you've got the hemorrhagic stroke. This is the leak. The pipe bursts and blood floods the surrounding area, causing a whole different kind of damage from pressure and chemical irritation. So just remember that. Blockage or leak. That's the fundamental choice. Now, this is super important to understand. While they're both incredibly serious, blockages, those ischemic strokes, are way, way more common. We're talking about 80% of all strokes. The leaks, they account for the other 20%. So since they're the big one, let's start there. Let's follow the path of the blockage. All right, path one, the blockage. So what is physically happening to the brain tissue when that lifeline of blood is just cut off? The reality here is, well, it's pretty grim. When brain tissue is starved of oxygen, it goes through something called liquefactive necrosis. And that's as bad as it sounds. The tissue literally starts to soften and dissolve. It turns into a liquid. The brain is, in a very real sense, digesting that part of itself. And you can see how this plays out over time. What's crazy is that for the first 24 hours or so, you might not see any change at all. But then, from day 2 to day 10, the area swells up and gets really soft. Fast forward 3 weeks or more, and the body's cleanup crew has come through. And what's left? Just a fluid-filled hole, a permanent empty space where that brain tissue used to be. We also have to talk about something called a TIA, or a mini-stroke. Think of these as temporary blockages. The clot is there for a few minutes, maybe an hour, but then it clears up on its own. But you can't just brush it off. A TIA is like a giant flashing red light. It's your brain's plumbing system sputtering and coughing, warning you that the pipes are getting seriously clogged, and a total system failure could be right around the corner. Okay, so that's the blockage. Now let's look at the other path. It's less common, sure, but it's often way more dramatic. Let's talk about the burst pipe.